So what we're gonna do in this video is we're gonna do a step-by-step drawing of each of the steps when mitosis is happening in a cell. Okay, so I'll be using a lot of colors in here. We have our color guide in this left area, and as we go along, I would be stating some stuff happening for each of the stages, and but I will not be really in particular with those particular things that are happening inside. Rather, I'll focus on how we determine it with drawing only. So let's start. Ta-da! Let's have prophase first. So for prophase, since this one is right after interphase, we could say that your cell has already grown bigger because it has, replicated everything inside it. So when drawing or trying to remember prophase, we have to remember still. Oh no, it's a wrong color. Oops. But it's erasable, that's fine. Okay, so for prophase, we have our cell membrane in there, and then obviously the star of the show, which is your chromosome. But since it's right after interphase, the chromosomes in here would still be shortening. It's still condensing. They still look like ramen noodles. That's how I see it. But in this stage of mitosis, there is still a nuclear membrane present. So you have to add that in there. And your centrioles are starting to be active in creating or adding more microtubules that will be later on used for the spindle fibers, which will be in light blue. Okay, like so. Some spindle fibers in there. So that's it. You'll be able to distinguish this from the other ones in a micrograph because of the how the chromosomes look like. They're not like the X figure or the Y figure that we are more how do you call it, more used to, so to speak. Next, so as this prophase is happening, these chromosomes in here again would be condensing, and then they would shorten. And what would happen to them is that they would try to move to a particular part of the cell. Okay, and that will be the center. So for that one, it will be shown in metaphase. Oops. Again, we have to draw your cell membrane, but no nuclear membrane this time. Your chromosomes have now already shortened and paired up into an actual chromosome shape. Let's only have two for this particular image because my space to draw is quite small. So it's also important to remember to add your centromere in the middle, because your centromere is where your spindle fibers will later on be attaching to. But before they could attach or whatnot, they need the organelle that will produce the microtubule where the connection will happen. There. So spindle fibers will be attaching to the centromere of your chromosomes. Always, one at each side. There would be some that are extending but are not attached to. That's fine. The more spindle fibers there are, I think the more strength or the faster the next step will be. But what's important in the metaphase portion is that there is this alignment of chromosomes in the middle. That's how you know it's metaphase. Chromosomes always in the middle. So, next one. After they are in the middle, the spindle fibers will shorten, and the shortening of that chromosome would be evident in anaphase. So, you draw your circle again to show your cell membrane. Again, there is no nuclear membrane in here. The microtubule producing organelle is still there, perpendicular to each other. The star of the show, chromosome, will be present. Chromosome present, but as you could see, they are already separated. The reason why they are separated is because of the presence of the shortening of the spindle fibers. Do we have a number of how much spindle fibers are actually there in one set of mitosis? There's no study about that as far as I know. So we could say there are like hundreds of thousands of spindle fibers in there. And these spindle fibers will be connecting to the centromere of your chromosome. So they're pulled apart by the shortening of the spindle fiber. So, once this one is occurring, your cell membrane, however, will be in the process of dividing itself as well. So, other than these chromosomes being separated apart, in telophase, your cell membrane will be trying to divide itself, sorry. Okay, and as it is trying to divide, of course, you would have to now secure your chromosomes inside a nuclear membrane, because technically this is your new cell, right? Replicated, that's why you have two, and then you have your centrosome in here. Your spindle fibers most likely have already disintegrated because they're done pulling apart the chromosome. So in telophase, we will not really see them anymore. Most likely they are cut into smaller pieces already or being used in another part of your cell. So, of course, the star of the show, your chromosome, they will be pairing up later on to form your chromosome. Okay, next one. Oh, the feature that is seen in telophase or is significant for telophase will be the presence of this furrow in here. This furrow, also known as the cleavage of your cell. And after that, your cell will not fully separate apart from each other during telophase. Rather, the separation of these two cells, of these two cells will be in the process we know as cytokinesis. So cytokinesis is all about the separation of both cells from each other. This image is not to scale, obviously, but the only thing that is important in here is your cell after or during cytokinesis is already separated, and either they would undergo new mitosis or they would stop their cell growth for a while depending on the command of the nucleus or the neighboring cell signal that is found inside your body, of course.
Okay, so in recap, let's go back to prophase. Yep, in prophase, the characteristic that you're looking for an image in a micrograph in prophase would be, of course, you have a cell membrane, you have nuclear membrane, but the chromosomes in here are still shortening. They are not yet formed into the X figure that we are more familiar with. This one is then followed by metaphase. Metaphase is characterized by a alignment of the chromosomes in the middle of the cell. In this area where it aligns is called as the equator, metaphase equator. Metaphase equator. Okay, that is the significant feature. Next one, this one is followed again by anaphase. In anaphase, what's important in here is that the chromosomes are pulled away from each other because of the shortening of your spindle fibers. Lastly, for mitosis, we have telophase in there. The most important feature of telophase is the presence of the furrow or the cleavage in between the cells, because the two daughter cells are now trying to separate from each other. Okay, but they will not fully separate from each other in this stage. That particular step would be done in cytokinesis. Oops. Okay, cytokinesis. This is where you will have two daughter cells. Why we call them daughter, I'm not really sure why, but we don't really call the original cell as a father cell either. We call it as a mother cell. Fancy. Okay, so that is it for Draw With Me Mitosis edition. Bye!